Welcome back. My name is Daniel Sills, and this is video check-in 4 for the University of Louisville Applied Robotics course. The goal of this course is to create a submersible robot that up until the midterm, the main goal is just to submerge and emerge from the water in a controlled manner. We've been provided a series of hardware for the course, including a Raspberry Pi and some other critical components, and then we've also been provided a budget in order to build out the robot ourselves in our own creative manner. In this week's agenda, I wanted to go over some electronics updates. I've had a long-running series of electronics issues that I wanted to go ahead and talk about the updates first. And then this week has been very CAD heavy, and I have 3D printed some specific parts. If you've seen slides like this similar in the past, then you know that this is a new graphic, and so I'm very excited to show off the CAD work that I've done. And then finally, I'll wrap up with future work as usual. So let's jump right into electronics.
All right, so I got access to an Arduino this week, and I was able to resolve a lot of the issues that I was having with the other board. So that is a huge win. Last week I was using a knockoff Arduino board or a generic brand Arduino board and was having some issues with it. So this time I have this program, I have it functional, and I'm able to use the PPM encoder library, which PPM stands for pulse position modulation. It is the communication method that our motor driver, runs with. And so I was actually able to, with the Arduino, I was able to validate that our PPM signal is actually producing PPM, which I'll switch you over here.
And so that's what we can see here, and we can vary this value. Here, we'll set it to 100% and hit upload. You'll see this momentarily freeze. Done uploading and continue. And now we're getting a different pulse position. So great. We have absolute confidence this is working. I have then plugged the whole setup in, similar to what we saw with the Raspberry Pi, and it doesn't work. So I'll talk about why on the next slide. So I finally started to investigate the battery as the culprit. Having gone through multiple attempts at creating PPM signal, I knew that the battery was the only thing that was consistent at this point, the battery and the motor. But I had proven that the motor can run just by plugging it straight into the battery. So now I needed to investigate some things. From the Amazon listing, we can see that our motor controllers claim that they need a power supply of a 2S/3S battery, cannot use a 4S. I had no idea what S meant, except that I was fairly confident that it was referring to LiPo battery cells, but I didn't know what that translated into. And so I was able to find this blog, AmPow, and so it talked about 2S and 3S configurations. So I was right, 2 and 3 cells, but the critical thing here is they have a standard voltage of 7.4 volts and 11.1 volts for a 2S and 3S. The battery I have been trying to use is a 3.7 volts, so a huge difference. So here's the plan. Growing up, I had one of these Traxxas Bandits. This is actually their TRX model, so I didn't have exactly this one, but I had one of these high-end electric RC cars, and they have an 8.4 volt nickel metal hydride battery in them. And so I can get access to one of these for free. And so I will be retrieving it as well as the Arduino that I mentioned in last week's video. The Arduino that I had this week is borrowed from the lab. And so that's the plan for the battery. All right, let's get into some hardware updates. I've got lots to show here.
This week I've done a ton of work in CAD, which has produced some pretty neat 3D printed components, so I wanted to quickly go over some of those components, their features, and then what this means for moving forward with construction. So jumping over into CAD, we have our model that we saw earlier in the video, And so you can kind of see these components. So right now, um, I have not started to cut the 2 foot segment of the 2-inch PVC pipe, but that's what all of these smaller pipe components are going to be made out of. So if we take away all of our PVC pipe components, it leaves us with these 2 components. So I have printed both of these components this week. So their main goal is to affix these pieces of pipe in a controlled and predictable manner to our to the central piece of pipe. And so both of these have a large radius that meets up with the pipe. They also have slots in them to allow me to zip tie these components to the PVC pipe as the primary affixing method. I may also use PVC glue between these components just to add an additional layer of rigidity, but the goal is hopefully for the mechanical zip ties to be the primary method that these are held in place. So I'll go ahead and add in our ballast tank and the pump housing. And so you can see that the pump housing is going to be a smaller piece. And so this will house our pumping motor, and then we'll have pipes flowing out of the back into the back of the ballast tanks. And then it will nestle above the ballast and beside the main chassis. And so we'll have a pair of these pipes on both sides. And so I've printed, so this has locations for both ballasts to be in a single component. So this reaches all the way underneath. And then this one just, you would have one tucked on each side, and it is printed to be longer so that you only need one of these, whereas I might have 2, even 3 of these throughout the entire chassis of the robot. So jumping back to real life here, we have our main housing of the robot, and it can sit on top of this chassis component, and that holds it very nicely. I've gone ahead and zip tied this one in place, and so I'm really enjoying how these parts came out. Lots of room for the zip ties to go through, making assembly very, very easy. And then I'll go ahead and flip it around like this, so I can place this here, and then this component can go in right like that. So this doesn't have the best fit, and I think that there's some things that I can do to adjust it going into the future, and it also may be an instance of it's the flex that this is experiencing, because it is not fully supported, and these do get quite a bit of flex. So that would mess with the radius on this, which would in turn mess with the fit of this. This is a cool component that I'm really excited about. I came to the realization that when this is placed in here, this is the peristaltic pump. It is paired with this guy. It goes on like that. And so then this motor turns and it moves and it turns the peristaltic pump. So this has tubing coming out of it, and so it has a pretty limited radius before these start to kink. And so I was concerned about that, and I needed a way to mount this inside of this tubing anyways. And so the plan that I came up with was to create a tilted mounting bracket in here. And so it will actually replace the black mounting bracket that you see on here. And so that fits in right like that. And then it will go in the end of the tube like that.
All right, and then to wrap us up as usual, I'll get into the future work that I want to get going. So obviously get the pumps running. This has been something that I have said on future work over and over again. This time I really do think I've got what it takes figured out. And so I want to use a benchtop power supply mainly to validate my Arduino code. From there, I will be able to start working on developing the system for controlling the Arduino using the Raspberry Pi. And so I probably plan to do that over I2C control. And so I'll have to figure that out. And then finally, I ordered a bunch of packages last week, and so I need to receive those packages, and that will enable me to start. And that will enable me to start building out the robot for its final configuration, or I say final, its configuration that will lead into the midterm. All right, thanks for watching, and I'll see you next week.